It's just this. Yes. All right, we're on 1.7 right now. So look, you can still take notes on this stuff. All right, it's just going to be a little different. I'm not going to be writing. I'm just going to be pointing and talking about what they show up here. You got to be kidding me. Oh, poor baby. All right. Here we go. Okay, we're going to talk about things that are three-dimensional now. The other lesson was two-dimensional figures, okay, like triangles. Put your desk down. So the last one we did two-dimensional figures. Okay, if you look at the top right here, what is this? Three-dimensional figures. Okay, we just did like triangles and quadrilaterals and pentagons and all that kind of stuff. They're just flat surfaces. This right here, these are called solids. Even though it might look kind of empty in there, okay, we call this thing a solid. All right, so first, let's talk about this word right here, a polyhedron. Polyhedron is basically, it's just a general name for like a three-dimensional flat figure, okay? So if all the sides are flat and not curved, there's no circles to it at all, we call this thing a polyhedron. All right, if there's any curves to it at all, it's not a polyhedron. So if you look at it, is this a polyhedron? Yeah, because it's all flat surfaces and it's all one solid. It's all closed, okay? There's no openings, there's no gaps. It's all closed. That's a polyhedron. This is a polyhedron right here. What about these things? Would these be considered polyhedrons? No, because they're curved. They're circles, okay? If there's circles, if there's any kind of a curve to it at all, it's not a polyhedron, okay? Polyhedrons are just, uh-oh, I went too far. Let's go back. There we go. A polyhedron is just all flat surfaces. If you look at it, a polyhedron always has two. Actually, I'm sorry, I didn't mean to say that. A prism. Let's talk about two types of polyhedrons. One is a prism, one's a pyramid. Let's see the difference between a prism and a pyramid. A prism's got two bases. You know how we had like a rectangle had a base and a height and that kind of thing? Well, this is a little bit of a different base. It has two bases. Look at both of the bases. They're both exactly the same. See the bottom of it that it's sitting on? That could be considered a base. And the top one, that could be considered a base. If I took them both apart and put them right on top of each other, they would be exactly the same. All right, so a prism has two bases. Look at a pyramid. A pyramid has only what? One base, okay? It comes up to a point. It doesn't go straight up to another base. But a prism, know the difference between the two. A prism has two bases. Does it make sense? All right. So we call those bases. Look at the sides of this thing. Do you see how it has that? Kind of make a rectangle right there, and this is a rectangle, that's a rectangle. You got how many sides here? 1, 2, 3, 4, 5, right? You got 5 sides. We call those the faces right there. F-A-C-E. That's a face. Okay, sometimes you just call it a side, but they call them the faces. Look at the actual line segments. Do you see that little line segment right here? And this line segment right here and right here? We call those the edges. They're the edges of our prism or of our polyhedron, okay? So we've got edges, we got bases, we have faces. We also have where these come together. See where all the line segments come together and make a point? We call it a vertex. So that's a vertex, vertex, vertex. Yeah, it's a point. A vertex is always a point. It's a point where those, they didn't write it in here. All right? But it's a point where those edges come together. Do you see that? This edge and this edge come together right at that point right there. That's a vertex. So there's a whole bunch of vertices, aren't there? There's this one, this one, this one, this one, this one. There's down here, 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 here. What is it? There are 10 of them, right? And there 10? 5 on the top, 5 on the bottom. Vertices, yep. Okay. Yeah. Vertices, just said it. It's where these two line segments come together to form a point. Okay? That's a vertex. Vertices is plural of vertex. We've discussed that before. All right. So anyway, there you go. Look at this thing right here. Look at a pyramid. Look at the difference between a pyramid and a prism. It has a base, doesn't it? But look at the sides. The sides just don't go straight up and down. Look at this side right here. This side went perpendicular. We can call that the height too. We'll see that in a few minutes. We can call that the height. The height is always perpendicular to the base. Put your hands down. Don't. Put your hands down. So look at this. This right here has a base, but look at the sides. The sides don't go straight up and down, do they? They slant up to a what? To a vertex or to a point, right? So this, all the sides right here, they slant up to a vertex. That word slant we're going to use in a little bit as well. All right? You getting these words now? All right? This is in the book. All right? You can look in the book. This exact graphic right here is in the book. Okay? Exactly like this. I'm just explaining what it says. Those are polyhedrons. One is a prism, one's a pyramid. Make sure you know the difference between the two of them. It's very important that you know the difference between the two. Now, we could have different bases. The base doesn't always have to be 5 sides. We could have a triangular prism, right, where the base is a triangle, but both the top and the bottom will be the same. You could have a rectangle as a base. We'd call that a rectangular prism, all right, where the top and the bottom be the same. This happens to be 5 sides, so we call this, get this word, it's a pentagonal prism. From pentagon, right? We just put an AL on there, and it sounds kind of cool. It's pentagonal. This one right here. If it's 5 sides, a pentagonal. What if it was a hexagon? What do you think we would call it? A hexagonal prism. Okay, be a hexagonal prism. Same thing with pyramid. You could have a pyramid with a base of a triangle. You could have a triangular pyramid. Okay, and what's the difference? What's the difference between a triangular pyramid and another pyramid? Well, the base is a triangle. What's this? Is this a triangular pyramid right here, this picture? Is it? What's the base? The base isn't a triangle. What is it? Okay. Well, it might be a square, but we'll say it's a rectangle. Okay. So we call that a rectangular pyramid. Got it? What if the base of it was this base, but these sides didn't go straight up, but they slanted up to one point? All right. So what if the base of this was a pentagon? We call this a what? A pentagonal what? No. Pyramid. If they all go up to one point, it's a pyramid, not a prism. Okay? So whatever the base is, that's what we call it. Okay? If it was a pentagon, we call it a pentagonal what? Pyramid. If this was a pentagon, which it is, we call this a pentagonal prism. You get it? Prism, the sides go straight up and down. Pyramid, they come to a point. And you can think like the pyramids in Egypt, right? Don't they all come to a point? They're supposed to, right? Unless time and all those years kind of wore it down. But yeah, they went all the way up to a point. So that's a pyramid. Look at these. These are not polyhedrons. Why are they not polyhedrons? They're circles, right? I got a circle here, got a circle here, got a circle here, okay? So these are not polyhedrons, but they do have their own name. Look at this one. This is kind of like a prism, isn't it? It's got 2 bases, right? Just like the prism had. But the base happens to be a circle, right? So the base is actually a circle, but look at the sides. The sides go straight up and down. You see it? Okay, it's perpendicular. This would be our height right here. It's perpendicular to the base. It's very, very close to a prism, except the base is a circle. Remember, we said circles are kind of special. It seems like they always give different names when you deal with a circle. All right? Look at this thing right here. What is this cone kind of like? Yeah, but as far as up here, remember we said a cylinder is kind of like a prism, and this cone is kind of like a pyramid, isn't it? Why? Because it has one base, and the sides all come up to a what? To a point, which is called the vertex. Everybody see that? All right, so it's kind of like a pyramid, isn't it? Except the base of it is a circle. All right? And yeah, you can think of it as an ice cream cone. That's why they call it an ice cream cone, because it's a shape of a cone. Turn it upside down, put some ice cream in it, you're good to go. All right, look at this thing, a sphere. Sphere is like a ball. All right, we have a center point. We call that the center of the sphere. And it's the same distance all throughout there. You can go in any direction from that center point. If you go the same distance in any direction, you have a sphere. Okay, so that's what we call that. It doesn't have any faces, doesn't have any edges, doesn't have a vertex, does it? Really, the only thing this has is a center, all right, and a radius. Do you see that little red line right there? We would consider that to be the radius. Look at this little red line right here, radius. What do you think this is? Radius. Do you get it? It's from the center to the outside of the circle. That's the radius. So all 3 of these have a radius. Everybody good with that? All right, let's see if you understood that. Determine whether this is a polyhedron. Is this thing right here a polyhedron? Yeah, it is. Okay, because they're all flat surfaces. It's all closed. It's a solid, so it's a polyhedron. It says identify. It means what kind of solid is it? We had two types. Yeah, say it, Michael. Right, it's a rectangular prism. Why'd you say rectangular? Because the what? The base is a rectangle. See how it's sitting right there? See ACDB? That's a rectangle, and it goes straight up and down, doesn't it? See, the straight up and down part, the height is perpendicular to the base, right? To the bottom of it. So yeah, it's a rectangular prism. Very good. It says if it's a polyhedron, which it is, we just said it was, name the bases. Well, how many bases does it have? It's got 2. All right, so let's do the top first. Let's start. We got to start somewhere. Let's start at E. What would you call it? E. Let's go this way. E what? G, H, F. Good. Or you could go the other way, couldn't you? E what? E, F, H, G. Did you have to start at E? No. Could have started at H if I wanted to. So I could have gone what? H, G, E, F. You got all kinds of different possibilities for that, don't you? All right. Now that's one base. That's the top base. What about the bottom of it? A, C, D, B. Or you could go A, what? B, D, C. Or you could start at B and go B, D, C, A. You get the idea, right? So those are the two bases. Even though we named them all kinds of different names, there's still only two bases. All right, so we got the bases. What about the faces? The faces. What about this one right here? What do we call that face? C, G, what'd you say? C, D, what? Oh, G. You said G, C, D, H. Okay, that's fine. And it doesn't matter where you start. You can't do this, though. You don't want to go G, what? D, and then H, C, right? You don't want to do that. If you start at one point, just make sure you go around the horn, right? Just like that. Is that the only face? You got this one on the right. Somebody name that for me. D, B, F, H, yeah. Okay, what about the one on the left? G what? G, E, A, C. What about the one more? The one in the back, right? E, A, what? B, F? Yeah? Okay, good. All right, so they could ask you that stuff. And in fact, they're going to. I'm going to give you a worksheet today where they give you a picture and you have to name those things. Pretty easy stuff, isn't it? No work to show, really, on those. All you do is look at it, write down an answer. It just takes a matter of a couple seconds. All right? Here's what, look. Here's the answer, guys. Here's the answer. It says a solid is formed by polygonal, right? You know how we said like rectangular, triangular, pentagonal? They say polygon, right? Polygonal faces, right? So it's a polyhedron. The bases are rectangles, which we said, right? And the solid is a rectangular prism, right? And we said that too. Good. Here's all the different possibilities for our answers, right? They even asked for the edges and the vertices. We didn't talk about that, but that's okay. Look at this thing. Now, let's be careful with this. We didn't quite talk about this. When we talked about the base, we kind of looked at it, what it was sitting on, right? But this time, it's not really sitting on the base here. Because remember, there's only two bases. So it's actually sitting on one of the faces, isn't it? All right? It sounds terrible, but watch. Right here, this is the base, isn't it? All right, because there's two of them. Because this and this, and it goes straight out from it. Do you see it? Because I can't consider this bottom. I can't consider OIHN. I can't consider that to be a base because do the sides go straight up and down, perpendicular? No, they don't. But look at this right here, this KLMNOP. I just did. I would call it KLMNOP. Just use all the letters. Start at one letter, just go a certain order, whatever order you want to go, and that's how you would name it. Okay? It is a polyhedron. Listen, it is a polyhedron. It's a polyhedron because they're all flat surfaces, right? It's closed in, it's a solid, and there's no curved surfaces to this, right? There's no circles, no curves. So it is a polyhedron, all right? Identify the solid. Well, how many sides do this thing have? There's 6 of them, so we call this a hexagonal prism. Very good, okay, because the sides go straight up and down. It's a hexagonal prism. Name the bases. Well, it's that one and this one. I'm not going to go through all these. The faces would be all the other sides, wouldn't it? Name this top face right here. K what? KLFE. All right, you could keep on going. There's a whole bunch of them. What about the edges? The edges are all the little line segments, right? So K what? KL, that's an edge. K what else? E, KP, right? They're all edges. You follow me? There's a ton of them, aren't there? Sit here. I don't want to sit here and name every single one of them. What about the vertices? Which ones are the vertices? Yeah, they're just the points, right? It's where the line segments come together to make a point. So it's K, it's L, it's M, it's O. You just name all the points, all right? There could be. Yep, like that. All right, so look, it's a hexagonal prism, just like we said, right? So this is the answer to it. And then there's all the bases, all the faces, all the edges, all the vertices, all right? So if you want to list them out, look at all those edges. I didn't want to read off all those, did I? Okay. All right, let's see what else we got. Look at this thing. What is this thing called? It's a cone. Is this a polyhedron?
No.
Why is it not a polyhedron?
They go into a point.
A circle.
Well, it's not because it goes to a point, because it's a circle, right? It's because of the circle, okay? Polyhedron doesn't have any curved surfaces at all, okay? So it's not a polyhedron, right? So it just says identify it. Well, it's a cone. That's it. That's all you got to do. It says if it's a polyhedron, name all those other things. Well, I don't have to do that, do I? Because it's not a polyhedron, so I'm good to go. Let's see what they say, all right? The base is a circle. There's one vertex, so it's a what? It's a cone, all right? Oh, by the way, let's go backwards a little bit. We didn't mention this. Where is it? There it is. We have a whole chapter on circles, but here's just a little preview. In order to name a circle, we always name it by the center of the circle. All right. So the center of the circle is point T. So guess what we call this? Circle what? Circle T. All right. And what is the vertex of this? Okay, it's W. Now it's not a vertex of a polyhedron, but it is the vertex of that cone. All right. So I just wanted to make sure we knew that. See that? It's got no faces or edges. The base is a circle T. The vertex is point W. Doesn't have any faces. Doesn't have any edges. All right. I got to move on because we're running out. I'll tell you what. I got to move on. Oh, look at that. It gives you an answer. That's a triangular pyramid. It's a little weird looking. What is that thing? That's a cylinder. Okay. What's that thing? Is it rectangular? Which one is the base? This is the base right here, isn't it? Okay, so what do you think it is? Okay. Yeah. All right. Okay, here's... forget that. Don't worry about that. All right, this is what I want to get to. This is where we're going to end up, okay? Now, look, you're not going to have to memorize these things, okay? So that's a relief, isn't it? So you don't have to memorize them, but you need to know how to use them, okay? That's just as important, maybe even more important than memorizing these things. So let me just go through as quickly as I can because we're running a little short on time. What do we got? 5th, 12:38. So I got maybe about 4 minutes left, okay? So here we go. Watch. T. They use T for the surface area. T probably for total is my guess, okay? Total surface area. So when I find the surface area, I'm trying to find the area of all of these different surfaces. It's not just one flat surface, is it? There's a whole bunch of surfaces on here. There's what? There's the... Get my mouse. Where is it? Okay, there it is. It got the top, got the bottom, got the left side, the right side, the front, and the back. If I want to find all those surfaces and add them up, this is a nice, easy way to do that. All right? So T represents surface area. All right? Make sure that you know that. Anybody writing that down? I see a few people writing. All right? So T represents the surface area. Equals what? P. What do you think the P is? They even do it in red right here to help you out. It's the perimeter, right? P, perimeter, right? So it's the perimeter of the base. You might want to jot that down. Now, they do tell you down here what it is, but you may want to put that in your notes. P is the perimeter of the base times the height. What is the height? The height goes from the top, from one base, perpendicular to the other base. That distance right there is the height. That's the H. Okay? Calvin, please. Come on. Why don't you write something down? Then you won't be so bored. How about that? That's a novel idea. All right, plus 2 times B. What is B? Is it just the base? Look at it. It's the what of the base? The area of the base. So you got to take a look at that base and figure it out. It's not always going to be a rectangle. The base could be a triangle. It could be a pentagon. But you don't know how to find the area of a pentagon right now. That's way later in the book. All right, so it'll probably be either a triangle or a rectangle because that's the only thing that you can find the area of right now. Okay? So that's what that means. So it's the perimeter of the base times the height, and then you add the area of the base, you double it, you add them together, and that's the total surface area. Okay? Make sure you know how to do that. Look at this. This is a little different. Look what the L is right here. The L is actually what we call the slant height. Write that down. L is the slant height. It goes from the top. So pretend you're sitting on top of this pyramid, okay? It'd be a little pointy up there, but you're not going to be there for long, okay? So you sit up to the top, and then if you slide straight down that side right there, okay, perpendicular to the base, if you straight down the middle like this, that would be the slant height. Okay, it's not the actual regular height. There is a regular height here. They should have put it in here. The regular height would be H. The regular height goes from the top straight down the middle to about right there. Do you see that? So if I was rappelling, okay, and I was on a rope, and they lowered me from the top, let's say it was open, and they lowered me straight down to the middle, that would be the regular height. Because you do have a regular height right there, don't you? So make sure you know the differences between the slant height and the regular height. Regular height is H, slant height is L. I guess they use L because slant, S-L, right, A-N-T. They don't want to use S, so they use L. All right? So make sure you know that. There's the formula. 1/2 P. What's P? It's the perimeter of the base, right? There it is. P, perimeter of the base, times L, which is the slant height, plus capital B, which is the area of the base. You don't have to memorize these things, but you need to know what they stand for, and when they give you those numbers, what to plug into that formula, okay? Look at this right here, a cylinder. Since it's a circle, we always have pi when we're dealing with circles. It's 2 pi RH. Well, what is the H? H is the height. Do you see it? It's the distance from one base down to the other, perpendicular distance. That's the height. What is the R? It's the radius. Plug it into that formula, you're good to go. Make sense? Look at this one. Which one's the slant height? That's the L. Okay, L is the slant height. The regular height is the H. You would do that for volume. So we've got surface area, we got volume. And a sphere, 4 pi r squared, r is the radius. All right, you can do the same thing with the volume. Time's about running out here. So use that right there. Make sure that you know where that is. Either it's in your notes or it's in the book. Okay, I don't have the book open right now. I'm not sure what page it's on, but it's in there. It will be. I'll give it to you on a quiz or a test. Okay, I will give you these formulas. All right, it's not on the worksheet. You're gonna have to look in the book yourself. But if we're gonna do a worksheet, yes, and we're doing this stuff on the worksheet. Okay. All right. Does that make any sense? I hope so. All right, let's stop this recording. I'll give you the worksheet, and then you can go.